Good day everyone. My name is Sri Vishnu Jaisilan and I am from class BMMM 1/1 and my metric number is B0920104006. And for this pneumatic and hydraulic assignment 2, I did choose the case study as system 1, and this is the diagram. I need to replicate it in the fluids in hydraulic. So for this mechanism, basically this chuck will advance and grab the hook, and by the help of rotary actuator it will twist it into 90 degrees and will retract it, holding it and dropping it. This is the basic one, and that stated here, and I did build based on those electrically controlled fluid circuit. Here you can see the hook ended here, and the chuck will be placed uh, double acting cylinder edge right here. Then after we activate this by this 4 by 2 double solenoid valve, uh, this cylinder will advance and will grab the chuck right here, will grab the end of the hook right here, and by the help of the rotary actuator it will twist it into 90 degrees. Then you will still holding it and retract it, then it will drop it. Then the cycle follows, and here the hook, it will be manually input by the magazine in the magazine. So we can proceed to the simulation. Right here we can see it didn't move, and now after I activate the first solenoid here, the pressure will go into this, will move to the here, the second sequence. It will go right here, the pressure will go right here and will push the cylinder rod, and the chuck will advance and grab the end of the hook here. It grabbed the end of the hook. After I will activate the second solenoid here, it will change into back. Then the rotary actuator will actually twist it into 90 degrees right here. It will twist into 90 degrees. Then it will holding it and retract it, then drop it. It twisted 90 degrees there, and it will holding it and retract it and then drop it. Here you can see I did set the rotation angle into 90 degrees, and I did let the distance ruler for here, because I need to grab the end of the hook only. That's why I did set the distance limit, that the chuck will go and grab the end of the hook and will retract it back only. As you can see the simulation two times again. Right here it advanced and grabbed the end of the hook, then it will twist 90 degrees and retrieve it. That's all from me. Thank you.
Hello everyone, I'm Hanusha Ilam from class FTKMP BMMM1. Today I'm going to talk about assignment 2 for pneumatic and hydraulics. I chose system 2 as my assignment question. The diagram below shows an outline design of a proposed machine to be used for a drilling hole in a workpiece that works as follows. And this is the procedure. First, the workpiece is put in position. Next, the guard must be lowered and the workpiece clamped by cylinder C. 3 seconds after the guard is lowered, the drilling commences automatically. The workpiece is fed against the drill by cylinder B, and this is double rod type cylinder with the rod fixed at each end. The speed of the feed must be controllable. Now we go and see the system which I made. Before I start, this is the system which I made, and this is the electrical circuit which makes the entire circuit to move. First of all, this is how the workpiece moves. Actually, the double acting cylinder rod moves in front and retract back when it gets the sensor from the push button over here. Once we got click the push button over here, it will be moved to the to in front, and once it get the hole in front of the workpiece, it will be get it will back retract back to the same position. The manometer shows 0.6, and the workpiece, this is the workpiece how it be in the position. This helps to make the workpiece go sit on the position. It's moved forward and retract back by the use of solenoid system. This is the 5 to 3 way system, which helps the entire this workpiece to set on the position to make a hole. And this is the air compressor, which gives which supply the entire which supply air to the entire system. And this is from my side. Thank you.
Good day everyone, my name is Jiviganesan of Sasidharan from BMMM 1 stroke 1. My matrix number is B092010-468. So I have choose system 3. So first of all let me explain what is it. So system 3 is actually a tube swagging machine. So I have been required to design a hydraulic system. So let us see. First, a tube is actually placed on the rest. So the process start button is initiated in this process. So the two end cylinders that acting at the low pressure advances and center the tube. This continues to the clamp cylinders to operate at high pressure. So when the clamps are in place, the pressure on the end cylinders is actually increased to force the end and switch the tube at both ends. So when the stop button is initiated, it makes the end cylinders actually retract and then releases the clamp cylinders. So then a rotary actuator actually ejects the tube into a receiver box. So now I have designed a circuit using fluid sim. Let us see. So this is the circuit which I have designed using fluid sim. So let me play first of all. So this is how it works. Okay now. So let me explain. The tube is actually placed at rest at first. So the double acting cylinder, which is acting as the end cylinders at low pressure, okay, so then it advances and center the tubes. So the two piston rod double acting cylinder representing the clamp at high pressure. So then once the two piston rod double acting cylinder in place, the pressure at double acting cylinder is actually increased and it forces out and switches the tube at its both end. So let me show the process. So this is the process which I have explained just now. Okay, now let us see. So the push button actually acts as stop button. So when the push button is pressed, it is initiated and the results to make the double acting cylinder retract, followed by the two piston double rod acting cylinder. So when we press the close button, this double acting cylinder actually retracts and the two rod piston double acting cylinder also retract. So finally, a semi actuator will proceed to eject the tube. So as a conclusion from this experiment, I have learned to design a circuit using fluid sim. Thank you.
Hi, my name is Chai Wong Jie, matrix number B0920100016 from 2 BMMM S1 Group 1 Group 3. For System 4, we need to design pneumatic system for furnace conveyor in figure below that works as follows. 1. The process initiates when the start button actuated. 2. The furnace door is opened and the trolley moves back 3 mm and drops the object into a tank underneath. 3. The door must be closed as soon as possible to reduce heat loss. 4. The trolley moves forward 15 cm to its normal position. Note that the trolley can be moved by two cylinders as shown in the figure to achieve position required. The door is operated by a motor and lead screw arrangement. List of components: we use two double-acting cylinder, three one-way flow control valve, one 3-2-way push-button valve, one 3-2-way roller valve, two 3-2-way roller trip valve, two 5-2-way valve, and six compressed air supply. This is the design circuit for System 4. There are 9 valves and 2 cylinders used. This is the design circuit function. Now we start the simulation. This is the start button. After pressing the push button, cylinder A will instruct. This means the furnace door will rise. Then cylinder B will outstroke to push the object into a tank underneath. Then cylinder A will outstroke as soon as possible to reduce heat loss. All the components will go back to their initial position. Now we explain the flow control chart. First, check the machine for leakage. Start the process by activating valve A. The system will start. Then valve B changes state. Cylinder A instructs the door raising. Piston strips valve C. Then valve D changes state. Cylinder B obstructs. Then the piston trips valve E. Cylinder B instructs. Piston trips valve F. Valve B changes to original state. Cylinder A obstructs and the system is stopped and ready to start again. For the discussion part, we will talk about the function of component. This is the symbol for one-way flow control valve. It regulates the piston speed of pneumatic drives during advance and return strokes. This is done by suitable restriction of the compressed air rate in supply air or exhaust air direction. With this type of control valve, there is only one direction where the flow control works. This means we can slow down the airflow to a cylinder by using flow control valves. For this symbol, the air will be restricted if flow from left side, because the ball will seal the bypass route and the air forced to pass through the restrictor. We can adjust the screw on the top of the restrictor to alter the flow. When the air flows from the right-hand side, the flow will not be restricted. This is the symbol for 3-2-way push-button valve. The left-hand side is the push button and the right-hand side is the spring. 3-2-way push-button valve has 3 connection ports and 2 states. 3 ports are inlet, outlet, and exhaust. The valve is actuated by pressing the push button. Releasing the push button returns the valve to the normal position via a return spring. And this is the symbol for 3-2-way roller trip valve. The left-hand side is the roller trip and the right-hand side is the spring. The roller lever valve is actuated when the roller lever is pressed, for example by the cam of a cylinder. The valve is returned to the normal position via a return spring after release of the roller lever. This is the symbol for 5 two-way valves. 5 two-way valve has 5 port 2-position valve that will put the air into one end of a double-acting device as well as allowing the other end vent to exhaust. The double pilot valve is actuated by applying pneumatic signals alternately to port left and right. It remains in its last switch position until a counter signal is received. This is the symbol for compressed air supply. Compressed air supply provides the needed compressed air. It contains a pressure control valve that can be adjusted to output the desired operating pressure. The actuators used in this system is push button, spring, roller trip, and roller. For conclusion, we have learned how to design circuit for a system by using FluidSim software and understand the function of component. Thank you.